Okay, we're at number 3, and we want to find an explicit formula for that sequence. Okay, so here's what I see. I see, I see fractions, right? Okay, and so the only thing that's not a fraction is this first one. And then I also see that I'm doing positive, negative, positive, negative, positive, negative. So ultimately, I'm going to have to actually look at that and kind of see what's going on. Now, the best thing to do right now is just kind of actually write a 1 over a 1 just to get started. And then I'm going to leave my numerators as negative. Okay, so I got negative 2/5, and then I've got a 4 over a 9, and then I have a negative 8 over a 13, and then a positive 16 over a 17. All right, so a couple of things that I see. One that I see is I am heading and adding 4 every single time in my denominator. So my denominator is actually going to be an arithmetic sequence. My numerator, if I look at my numerator, and I actually am going to rewrite it, and I'll just do it in red right above. Forget about that's a 4, by the way. That's terribly written. The numerator is actually, ignore the negatives. Remember, guys, I told you to ignore the negatives because ultimately it is one simple quick fix at the very end, right after you've written basically everything else. If you look and ignoring the negatives, this is just a plain, let me adjust the guard here. My wrist keeps hitting the bottom. It is a 2 to the first power, a 2 squared, a 2 cubed, a 2 to the fourth power, and this, of course, would be a 2 to the 0 power. So it looks like my numerators are going to be 2 raised to an exponent. My denominator is going to be an arithmetic sequence. So if I go real quick, I'm going to write that really quickly. So the denominator would be, my first term is 1 plus n minus 1 times my common difference of 4. So 1 plus 4n minus a 4. So it's really going to be a 4n minus a 3. So when I go to write my generic term, a sub n equals, all right, my denominator can be a 4n minus 3. Okay. My numerator is going to be 2 raised to an exponent. Okay, so 2 raised to an exponent somehow. Now, what you can do is you can do a 2, and we can raise it to an exponent. Now, because we are alternating back and forth, you have either the option to put a negative 1 out front, and then you have to worry about some exponent here, or you can actually just make your 2 a negative. Okay, so we're going to make that 2 a negative, and then we're going to look at how we have to raise that. If we are doing this, and remember we're trying to do this for n greater than or equal to 1, so if I plug a 1 in my denominator, 4 times 1 is 4 minus 3. So 4 minus 3 gives me a 1 for my first denominator, which is exactly what I need. If I plug a 2 in, 4 times 2 is 8 minus a 3, which gives me my 5, which is exactly what I need. So my denominator is set. Now, what I really want up here in my numerator, if I just plug an n here for my exponent, when I do negative 2 raised to the first power, I get a negative 2. Okay? The problem is I need to start with this 1 over here. The very first thing that I want is it raised to the 0 power. So then the only thing I have to do is subtract 1 there. Okay? And again, notice how I kind of ignored the positive negative aspect of it until the very end.